So we're now starting the second part of this unit, which is on forces. So to understand forces, we have to learn how to analyze it. So today you're going to learn about how to draw this style of drawing called free body diagram. We're going to use a specific types of diagram to learn how to analyze forces acting on an object. So forces in general, it's a push or a pull. And there's two types of force. One is a contact force when they say when one object pushes on another and it started moving, so there's actually touching involved. But then there's another type of force that are called action at a distance forces. Common ones are like force of gravity, right? So if you have two objects, they're spaced fairly far from each other, but you can still have one acting on another. The other types of forces are like magnetic forces. Have you ever played with magnets? When you have two objects and they are like poles facing each other, it will start repelling. And the other ones are electric force. That's also another example of action at a distance force. I have a proton and an electron. They will attract each other. So on a very small scale, they will actually travel from one to another and start accelerating. Force is still considered to be a vector, so it does have a direction and it has a size. And the unit that they use is called newtons, capital N. And the definition of what 1 newton is 1 kilogram meters per second square. Common force that we would be using in this course, the first one is called the applied force, FA. So basically when you have an object pushing or pulling, anything like that, and you would notice that whatever the direction is, so if I have 5 newton to the right, the direction is to the right. So it's whatever the direction of the force is, that's what this is. Okay, normal force is the other thing that we would be talking about. And normal force, it's any supporting force when an object is resting on a surface. So right now I assume you're sitting down. If I ask you what are the forces that are acting on you right now, very easily, I'm going to actually go ahead and draw. So you're sitting on a chair right now, okay? Probably most of you are going to be able to answer when I say, what are the forces acting on you? You probably would tell me the first one is gravity, okay? Gravity is acting downwards on your person. But then the question is, how come you're not flying to the center of the earth? Because there's always something else holding you upwards. Your chair is holding you upwards. And so every time when we have forces like that, we call it the normal force. It has to be resting on a surface. So on your chair, that's where you're resting. Force of normal is holding up. Your pen, your phone that is on your table right now, force of gravity is acting downwards, but at the same time, your table is holding it upwards. That's force of normal. And the direction for force of normal is always perpendicular to the surface. So that's why if I have a table here or the chair, it's going upwards. So a slight tricky one would be, how about if I have an object that is, a box that is on a slope, or a skier that is going downhill? You would probably be able to tell me that force of gravity is still going downwards. But if I follow the rules for force of normal, it's 90 degrees. That's what perpendicular is, right? So 90 degrees to the surface, holding it up like that, right? So this will become your force of normal. So I can give you a trick on the question and put it on an angle. You need to know that force of normal, always perpendicular to the surface. The surface is the ground. This is the surface, right? The next type of force is called the force of friction. We use the symbol FF. It's basically forces that the object's surface has act to oppose the motion. So that's why obviously the direction of force of friction would be opposing the motion. Meaning if the object is going towards the right hand side, force of friction would be to the left. Next one is called air resistance. F air. When something is moving through the air, we consider that there is force of friction called air friction. Often we neglect it because a lot of time we'll be saying, we're probably talking more about friction in contacting surface and stuff like that. So a lot of time when the object is just traveling on the road, we ignored it. But if we want to be really specific, you can still have air friction for a car that's driving on a highway. Have you ever experienced really strong wind that's air friction, right? But at most of the time in physics when we're solving problem, we ignore that. Force of tension, tension force, is every time if I have a force that is exerted by string, rope, cable, fiber. Okay, so if I have an object that is hanging by a rope, say if I have an object that is hanging by a rope, okay, it will, along the rope, will experience this force called force of tension, but at the same time, force of gravity is acting on it. Okay, if I have a picture frame, sometimes people hang their picture frame weirdly. They can kind of mount it with two strings like that. Then you would have force of tension. As long as it has a rope, it will have force of tension. And notice the direction is always along the string, pointing away from the object. Okay, so that's the direction of force of tension. So along the string, away from the object. It's always a pulling force. Last one we already talked about, common forces or force of gravity. Basically, it's always between two masses, but on Earth, because Earth is so massive, force of gravity is like a lot bigger than between a pencil and a ruler, because they're really small forces. And so we most of the time just consider the force that are from the Earth. So that's why the direction that we're using is force of gravity is referring to the force acting from the Earth to whatever the object is. So the next thing we're going to talk about is how we analyze forces. We use this thing called the free body diagram, FBD. So that's going to be the short form that we're going to be using. So a system diagram shows all objects under analysis. So a free body diagram, what we do is I basically just use a simple drawing, and we show all the forces that are acting on it. The forces will be these forces that we're talking about. So there's 6 types to choose from. And whatever is applicable, you're going to have to put it on the picture. Okay, and the rule says you always use a box. You would always draw the XY axis. You will always use an arrow pointing away from the object, and you would label the forces. So let's do the examples together. Okay, so I'm just going to write it at the side, some of the ones that we could have. I have applied force, I have friction, I have air friction, I have force of tension, I have force of normal, and I have force of gravity. Okay, force of gravity are going to be on everything. You are going to put that downwards on everything that you draw. Okay, apply force is when someone's pulling it. When you have force of tension would be anytime if you have any string or rope. Force of normal if it's sitting on a surface. And then the other ones you're gonna have to see the situation. Okay, so let's see. A fish is held by a fishing line. So the object we're gonna use, so follow the rules, right? We always draw a box first. Okay, that's your first step. Every one of these pictures are going to be worth 2 marks, right? So make sure you put everything. Okay, and it's held by a fishing line. When I have a fishing line, does it make sense that I'm going to have a force of tension? Okay, so I have a fish that's held upwards by a fishing line. I have force of tension. You put a dot in the center, and then we said that force of gravity is acting on everything. Okay, so that's the first step. I draw a box, I label all the forces. I don't have an applied force. I don't have a friction, air friction, like it doesn't, none of the other ones is applying to it. It's not sitting on a surface, so I don't have force of normal. Okay, the next thing you do is you have to write your XY axes. 99% of the time you just put that. The last one is you're going to have to say the direction of where it's moving. But it's just being held there, so there is no acceleration. So I'm going to write A equals to 0. 1 mark, half a mark, and half a mark. Right? You have to label all your forces. Okay, next one. Try it on your own. A volleyball is held by hand. I know we use a box for a volleyball. What are the forces from the 6? Every time you put your force of gravity, it's being held up, right? It's being held up by something that is the surface. Your hand becomes the surface holding it up. You have force of normal. You draw your XY, and because this is being held, my acceleration is 0, so I don't have a direction. A book is pushed across the desk by a horizontal force. Okay, a little bit more fun now. Okay, I have a book. What are the forces that are acting on it? Hopefully you got your force of gravity. You put it on every single one of these free body diagrams. What are the names of these diagram again? Yes, free body diagram. Okay, it is sitting on a desk. That means it has force of normal. Okay, whenever there's a surface, there is a force of normal. Okay, I have something that's pushing it horizontal. There is a horizontal force. We call that FA, the applied force. And this is something that we don't say out loud, but if it's moving to the right, there's going to be friction force that is going against it. So I have FF. Unless if the question say, assume there is no friction between the desk and the book, then you don't put your FF. If it doesn't specify, you have to say it.